is going to serve as a demonstration for both what entails a lab report, and then I'll show you an example of a model one that I've made as well to help you on your future reports itself. So the first portion is our title, simply what's the lab itself actually called. Next portion is our purpose. So what is the purpose of our experiment? A good sentence starter we can see right here is the purpose of this experiment is to do what? So for example, we just recently did the water cycle, so the purpose of our experiment is to see the water cycle happen in a box. Hypothesis. This is our educated guess as to the outcome of the experiment. It is one sentence in an if-then format. It's if I do this, then this will happen. So for example, if I heat water in a box, then when it rises to the top, it will condense. That's a good example of an if-then hypothesis. Materials are a list of everything we need to do the experiment. This is also using exact measurements. So if we use 50 milliliters of water, we want to write 50 milliliters of water. The reason we need the materials and exact measurements is because real scientists redo experiments all the time to get the same result. Our procedure is how and why. This needs to be done in what's known as list order, and that is the example of 1 sentence, next line, 2 sentence, next line, 3 sentence, next line. It's not a paragraph. List order means I can just read in a row and I know what I'm doing. The next portion we're going to be looking at is our data and our observations. Our data and our observations always include either some form of graph or chart to display what's going on. We want some sort of visual understanding. We also want either a mini paragraph or notes along with it to explain what we see in the picture. Our analysis. This is the how and why portion. This is known as the discussion phase, and this is not just a summary, right? It's explaining why the things happen. So a summary would be, we heated water, it evaporated, it rose to the top, it condensed. That's a summary. But that's not the why. To say that we heated water to the point where the molecules vibrated fast enough that they could escape from the actual liquid stage and turn into a gas, and then as they rise, they cool down and turn back into a liquid through condensation, that is analysis. And our conclusion, we're looking at 3 sentences. Was our hypothesis yes, correct or incorrect? Were there any errors? How would we take this experiment further? And when we take the experiment further, we actually want to change it. Simply changing the type of liquid might not change the experiment. So let me show you what the actual example is from the lab I created myself. So this lab is based off of the water cycle we just did. You notice our title, water cycle in a box. It directly relates to what we did. The purpose of this lab is to show how thermal energy drives the water cycle by representing the water cycle in a shoebox. Hypothesis, if I use a lamp to heat up water inside of a shoebox, then I'll be able to see the 3 stages of the water cycle. Our materials, 1 lamp, 73-watt bulb, very specific, you notice, clear shoebox with lid, 1 cup water, 1 petri dish, 1 can of Play-Doh, and ice. You notice I left the ice not as specific because the ice could change perhaps. Procedures. Once again, you'll notice list order step by step. So 1, you gather all your materials as listed above. 2, create a mold of your mountain and place it in your box. 3, pour 1 cup of water into your box and cover with the lid. You may use hot water if necessary to make the experiment go faster, which we did for this one. Turn on the lamp and place it on one side of the box so that it's touching the box's surface. Place ice in the petri dish and place it on the opposite side of the box away from the lamp. Record observations every 3 to 5 minutes. After 15 minutes, take the cover off the box, make observations on the difference between the portion of the box underneath the lamp and the portion underneath the ice, and clean up all our materials. On to our data and analysis. So you notice, right? Very specific, we use color here. So I've included all 8 parts of the water cycle as listed on the original rubric, right? So accumulation, we have runoff, we have Play-Doh representing the runoff, we have a petri dish with ice representing the troposphere, precipitation, solar radiation, condensation. And you notice I've explained what the purpose of everything is, right? I didn't just say this is runoff, I explained what runoff does. You'll also notice that throughout here I've talked about my unobservable mechanisms. So evaporation, gravity, things you can't see, but things you still know are there. Our example of analysis. So this lab showed how the water cycle can occur inside a box. The first step of this lab is to use a lamp to heat up the water to the point that the water molecules vibrate fast enough that they are able to escape the surface of the water, thus changing from liquid to a gas through the process of evaporation. Evaporation is an unobservable mechanism, meaning that we know that it's happening but cannot see it. The reason that we know that evaporation occurred is because condensation happened on the lid of the box. As the hot water particles, which are now in gas form, rise up, they're attracted to the cooler surface of the ice, representing the troposphere. Once the evaporated water makes contact with the ice, it loses its thermal energy and turns back into a liquid. As more of the water droplets gather under the ice, they get heavier. Eventually, they become so heavy that another unobservable mechanism, gravity, exerts its force on them, causing them to precipitate down. This precipitation, in turn, causes runoff on the face of the mountain, represented by the Play-Doh, and accumulates in the bottom of the bin, which represents an ocean or lake. And lastly, our conclusion. In conclusion, my hypothesis was correct, because I was able to see all three parts of the water cycle through the lab demonstration. The mistake that I made was I used slightly over a cup of water. In order to take this lab further, I would like to use dyed water with some soil on the bottom of the bin so that I could see infiltration as well. This is going to wrap up the video portion of how to write a lab report. I encourage you to follow this anytime you either do a lab report or have to redo a lab report. But the big focus here is on how direct and specific we are. Thank you. Have a good day.